Welcome again to another segment of my chemistry, more concept as we continue, showing you how to, answer questions when they give you from a balanced chemical equation. So this is what we are going to look at, and this is an examination question from the Examination Council of Zambia, ECZ. So the question there says, consider the reaction below. So you can see the reaction below. This is uranium tetrafluoride reacting with magnesium to produce magnesium fluoride and also uranium. Then the equation is already balanced, so we don't need to worry about that. So it says, using this reaction, decide whether uranium is more or less reactive. So they want us to decide using that reaction whether uranium is more or less reactive than magnesium. So we are comparing magnesium to uranium. Then they say justify your answer. In other words, give a reason for your answer. So when you find such a question, what should come to your mind? There's always what we simply call a displacement reaction. Now, according to the displacement reaction, it states that a more reactive metal will displace a less reactive metal from its compound. For example, if you notice here, uranium tetrafluoride is in a compound because it has actually combined with fluorine, and magnesium is alone. But now what is happening is that after the reaction takes place, you can see that the uranium is no longer having fluorine, but it has actually been replaced by magnesium. So this shows that magnesium is actually more reactive than uranium because the magnesium has displaced the uranium from its compound. So that tells you that magnesium is actually more reactive. So now let's get back to the question. It says, using this reaction, decide whether uranium is more or less reactive than magnesium. Of course, because magnesium has displaced uranium, it simply means that uranium is actually less reactive. So we can say uranium is less reactive. So it is less reactive. Now, if you remember, the question was saying justify your answer. So why are we saying it is less reactive? So we can simply say, maybe in short, we can say, it has, been displaced. It has actually been displaced, from its compound. So it has actually been displaced from its compound. No wonder it is actually now alone there. So it is actually less reactive. Then the B part there says that B1, B Roman 1 says calculate the relative molecular mass of uranium tetrafluoride. So remember, they want you to calculate the relative molecular mass of this compound, the uranium tetrafluoride. So it's U, F, and F4. So remember, you can look at how many fluorines are there and how many, in this case, uranium are actually there. You can check your periodic table to actually, check out the atomic masses for uranium. You can actually check those out. So if I look at this one, for fluorine, how many fluorine atoms are there? There are 4 multiplied by the atomic mass for fluorine, which is actually 19. So we are going to multiply. Then uranium is just 1 multiplied by the atomic mass of uranium, which in this case, we can, let me slightly check the periodic table so that I can just confirm. Of course, you can have, let's use the one for the periodic table, which is, in this case, 238. So that is going to be 238. So we can actually multiply that using the calculator. So that is going to be 4 multiplied by 19. That will give me 76. Then 1 times 238 will still give me 238. Then you add that. So you add these two to give you what we are calling as being the MR, or the relative molecular mass. So 76 plus 238, that is giving me 314. So this is gram per mole. That's what we mean. So that is the relative molecular mass of uranium tetrafluoride. All right. So now the last question there, B2, Roman 2 says, how many kilograms of uranium? So how many kilograms of uranium can be formed in the above reaction using 24 kilograms of magnesium? So they want us to know how many kilograms of uranium can be formed when we use 24 kilograms of magnesium. Like I said, allow me just to clean up this section so that I can create space which we can use to actually calculate that. So you go back again to your balanced chemical equation. What you do, you find the total mass of what's the total mass of that guy that we are having there. So let me just write the equation there. Uranium tetrafluoride was reacting with magnesium to produce magnesium fluoride plus uranium. So from the balanced chemical equation, you can find the mass, the total mass of magnesium here. So remember, there are 2 magnesium times the atomic mass of magnesium, which is 24. So that will give us 48 grams. Then uranium is only 1, so it will give us 238 grams. So from the balanced chemical equation, you can say 48 grams of magnesium produces what mass of uranium? It produces 238 grams of uranium. Now the question was saying how many kilograms. In other words, when they ask you how many kilograms, the question is telling you what mass of uranium can be formed in the above reaction using 24 kg of magnesium. Well, some people may be tempted starting to convert what we are calling as being 24 kilograms. There's no need of you converting. They can also give you tons. There's no need of you converting. You can compare the same way we have compared the masses in grams. You can use your kilograms because you'll be getting your answer, the other answer in kilograms. If they gave you in tons, you just use that because you're going to get the other answer in tons as well. So there's no need. Maybe at the end of it, if the options is in grams, that's when you can actually convert. So I'm going to say, suppose now I use 24 kilograms of magnesium, then what mass of uranium will I produce? Cross multiply. Remember, I'm using kilograms, so my answer will still be in kilograms. So it will be x times 48. That is going to give me 48x is equal to 24 multiplied by 238. To find x, I'll divide 48. What I do this side, I'll do it the other side. So this and that will cancel. Therefore, my x will be equal to, we can apply the calculator there, 24 multiplied by 238. That answer we get, we divide by 48. So this is going to give me 119 kilograms of uranium. So meaning 119 grams of uranium will be formed when you use, 24 kg of magnesium. So in my next, discussion that I'm going to have, I'm going to look at, concentration. So please watch out for the next video where I'm actually going to look at, not really concentration because we talked about that. So I'll be talking about what we are calling as being dilutions. So I'll be looking at dilution when things are being diluted. Thank you so much for paying attention. See you in my next video.